Okay, this is continuing on with the Unit 4A Test B, and this is the second video. I should be able to get this done in 2 videos this time. Number 9 is exactly like a problem that was on the study guide, and it has to deal with 2 circles that one's dilated to form the other. And when circles are dilated, they can either be enlarged or reduced. So knowing that, we know that the radii are not always equal to each other. So we can mark out A. Then it says the length of any chord in circle P is greater than the length of any chord in circle P prime. Well, we know that's not true because it can be enlarged or reduced, either one. The next one, it says the diameter of P is greater than the diameter of P prime. Again, same reason, that is not correct. And the next one has to deal with the formula of the circumference. And it says the ratio of the circumference to the diameter is always the same. And the ratio of the circumference to the diameter of any circle is always pi, no matter what size circle it is, as long as it's a circle. So the answer here is D, and that will always hold true. Number 10 deals with the equation of the circle again, so I'm going to go ahead and write that formula. And this formula is definitely on your formula sheet. We are given the center of the circle as being 10, negative 7, so above that I automatically write x and k. And then I know that negative 14, 0 is a point that is on the circle. So I'm going to use this point to find r squared. I'm going to plug it into my formula, or my circle equation, and solve for r squared. So here I have x minus 10 squared plus y plus 7 squared is equal to, and I don't know what r squared is yet, but I can plug in my points here, negative 14 minus 10 squared plus 0 plus 7 squared, and so that's negative 24 squared plus 7 squared, and then I use my calculator. 24 squared plus 7 squared is equal to 625. So this ends up being the equation of my circle, and would be my answer down here in this blank. Now, to find the radius, I know r squared is equal to 625, so I can take the square root, and r is equal to 25. So the radius of my circle is 25. Number 11. This is where I have to complete the square and follow the steps to do that, to write the standard form of the equation. So this up here is the standard form of the equation. So I have to rearrange things, and I have to group first my x's, and I know I'm going to have to complete the square. So I'm going to add a number, and I don't know what that number is yet, so I'm going to leave it blank. And I'm going to group my y's, and I'm going to add some number, and I'm going to move everything else to the other side. So I have negative 8 plus 5 is still there. And then I have those 2 numbers I'm going to add to the left side, so I have to add them again to the right side. So my standard equation looks something like this. So I have x and y. And I know that c is equal to b divided by 2 squared. Now, in this problem, I need to first take b and divide it by 2. So 8 divided by 2 is a positive 4. So that goes in my standard equation, and then I take 4 and I square it. So that's plus 16, and then I have to add 16 to both sides. My next, dealing with the y to complete the square, I take 12 and divide it by 2, and it's positive 12, so it ends up being positive 6. And then I square, so it becomes 36. And then to find what r squared is, I just take negative 8 plus 5 plus 16 plus 36, and it ends up being equal to 49. So this is my equation of my circle, and then I can use this equation to actually graph my points. So my center is at negative 4 and negative 6, so I go down 6 right here. And then my radius is 7, so it's going to end up being this way, and this way, and this way 7, and down 7. And so my circle looks something like this. And again, it doesn't have to be perfect, but that is what the circle will look like. Going on to the back page, Number 12, I am just finding the area of the whole pizza, and it is divided into 8 equal slices. So when I find the area of the whole pizza, which is pi r squared, if I divide it by 8, that's going to equal a slice of pizza. So here I have pi, and my radius is 12. 12 squared divided by 8, and I plug it into the calculator. So it's pi times, because 12 squared is 44, divide that by 56, and I'm dealing with its squared area. It has to deal with the arc, formula, well, our reference form, 2 pi r, just an 80 go, and then just divide my circumference. And I'm going to wait, let the video catch up. So I have 2 pi times 12 divided by 8. Divided by 8, and then that becomes 9.4 inches. And it's just the length of the side, so it's just inches. Moving on along to this one. This has to do with Cavalieri's theorem, principle, and I know that this ends up being the height of this one. I don't have to use the Pythagorean theorem. And it's a cylinder, so it's pi r squared h. So it's pi times 2 squared times 7. So pi times 2 times 7 times 2 again, because it's 2 squared. And that's 28 pi, and then plugging it in is 87.96, so it said round to the nearest tenth, so it should be 88.0 inches cubed. And this would be my correct final answer. Now, the right cone, I need to change this to inches, and my units are inches, and I have pi squared h by 3. I notice that I'm given height. I don't have h, so I have to use Pythagorean h. The video to catch up. So that's going to be my 8.4. So I have h squared is equal to squared, 12 squared, 6 squared, 8. So it's equal to 8. Square root, find out what the height is, and it is actually equal to 4. And knowing this information, plug it in for the video to catch up. So I have pi, and I have 6 squared times 10.4 divided by 3. So I do pi times 6 squared times 10.4 divided by 3. And so my answer is 392.1 inches cubed. I think I'm going to save for video 3 the last two, because the video is getting long.